Indosaw is India's one of the largest manufacturing company in educational science lab equipments. It has a wide range of equipment for making science learning fun. We present here an experiment suitable for training in experimental physics, which illustrates a novel technique of behavior of diamagnetic, paramagnetic and ferromagnetic materials. At first, we will look into the items provided with this experimental setup. The first item is DC power supply of 0 to 30 volt, 10 ampere, along with a power cord. Multimeter. There will be 2 coils of 500 turns, 2 yokes, 1 U-core, 2 clamps with screws, and 2 pins. The other items which are provided with this experimental kits are 1 shaped base, 1 shaped rod, and 1 attachment assembly. There will be 2 pair of red and black leads of length 100 cm, and 1 yellow lead of 50 cm. 1 multimeter also will be provided. 3 sample of aluminium, bismuth, and iron are also provided along with hook. 1 thread reel is also provided. In this experiment, we will study the behavior of diamagnetic, paramagnetic and ferromagnetic substances in an inhomogeneous magnetic field. These are the items required to perform the first experiment. DC power supply of 0 to 30 volt, digital multimeter, U-core, clamps with screws, yokes, pins, leads, L-shaped rod, attachment assembly, iron, bismuth, and aluminium sample, power cord, and a shaped base. Now we will look how the experiment can be performed step by step. In the first step, place the DC regulated power supply on the table. In the next step, plug the power cord into socket at the back of the power supply unit. Plug the other end of the power cord into a grounded socket. Place the U-core in front of the power supply. Insert the 500 turns coils into the 2 arms of the U-core, as shown. Place one of the yoke above one of the arm of the U-core, as shown. Place the another yoke above another arm of the U-core, as shown. Hold one of the clamp in your hand, and loosen the screw by rotating the knob anti-clockwise. Repeat this procedure for the another clamp also. Place the clamp over the top of the yoke so that it hangs at that position. Insert one of the pin into the clamp in such a way so that it also passes through the hole present within the U-core. Similarly, place the clamp above another yoke, and insert the pin into the corresponding pinhole. Now tighten both the screws of both clamps by rotating the K and OD of the screw clockwise. This whole assembly is called now electromagnet assembly. Keep in mind that the distance between the 2 yokes should be around 1 cm to 2 cm. We also refer the yokes as the pole pieces of the electromagnet. If the distance between the pole pieces is not set up in the range of 1 cm, 2 cm, then loosen the screw, then set the pole pieces at desired distance, and then tighten the knob of the screw. Now place the A-shaped base behind the electromagnet assembly. Insert the L-shaped rod into the central slot of the A-shaped base and tighten the screw. Now attach the attachment assembly into top corner of the L-shaped base as shown. Take a piece of thread. Bind one end of the thread at the central groove of the bismuth sample tightly. Now bind the other end of the thread to the S-shaped hook. Now hang the S-shaped hook from the hook located in the attachment assembly in such a manner so that the sample suspends between the 2 pole pieces of the electromagnet. You may have to change the height of the L-shaped rod for this purpose. Also, you may need to wind the thread a few turns over the S-shaped screw to get the desired height. Rotate the sample by hand so that it gets a line parallel to the axis of the pole pieces of the electromagnet. Connect the red lead between the red sockets of the power supply and the electromagnet assembly. Connect the yellow lead between the yellow sockets of the coils of the electromagnet assembly. After that, connect the black lead between the black sockets of the power supply unit and of the right-sided coil of the electromagnet assembly. Rotate all the knobs of the power supply to their minimum position. Now switch on the power supply. When the power supply is switched on, the current and voltage display will indicate 0 value. Now turn the coarse and fine knob of the current control of the power supply to their maximum position. Gradually increase the current through the coils by turning the voltage adjustment knob in the clockwise direction till the current display shows a value of 8 ampere. Current through the coils will produce a magnetic field of the order of 1 Tesla in between the pole pieces. As a result, the diamagnetic sample, bismuth, will orient itself perpendicular to the magnetic field, that is, perpendicular to the axis of the pole pieces. Now rotate the voltage adjusting knobs of the power supply anti-clockwise to their minimum positions. As a result, the bismuth sample will now rotate to its previous position, that is, almost parallel to the axis of the pole pieces. Also, rotate the current control knobs of the power supply anti-clockwise to their minimum positions. After that, switch off the power supply. Now replace the bismuth sample by aluminium sample and align it perpendicular to the axis of the pole pieces. Now switch on the magnetic field, as mentioned in the previous steps. Observe that the paramagnetic sample, aluminium, will align itself parallel to the magnetic field. Bring the voltage adjusting knobs and the current control knobs to their minimum positions respectively by rotating the respective knobs in anti-clockwise directions. It will bring back the aluminium sample to its initial position. Switch off the power supply. Replace the aluminium sample by iron sample. The iron sample will stick to one of the pole pieces of the electromagnet assembly even when the power supply is switched off. It happens so because the ferromagnetic core of the pole pieces retains some amount of magnetization even when the external source of magnetization is removed. Diamagnetic substances are those substances which are feebly repelled by a magnet, for example antimony, bismuth, copper, gold, silver, quartz, mercury, alcohol, water, hydrogen, air, argon. Paramagnetic substances are those substances which are feebly attracted by a magnet, for example aluminium, chromium, alkali and alkaline earth metals, platinum, oxygen. Ferromagnetic substances are those substances which are strongly attracted by a magnet, for example iron, cobalt, nickel, gadolinium, dysprosium. Thank you for watching us. Please stay with us at www.indosaw.com.